x of these type. Limit as x goes
Yeah.
to minus infinity. Okay.
I could get some from WebAssign and like screenshot and send it to you.
That would be good to do. I
Okay.
can certainly find some, but it's better if they're the problems you think you'll see, and they're likely pulling from the same ones.
Yeah. Okay. I'll look through the homework real quick. Okay. And then you said email back to the.
Yeah, you can either send direct to me, or you've already replied to the booking email, which I found. If you want to look in your sent mail, you'll see that as well.
Okay, I'll just do that real quick and then. Okay, I think I just responded. I'm not sure.
Yes, I got it here. So I see a reply. I don't see anything attached to it though. So
Okay, that's what I thought. It looked like they didn't actually go through. I'll send it again. Okay. There we go.
great. Let me check here. They're there. Okay. So I got a bunch here. It's like the first one I see is a question about annual imports. Is that one you'd like to start with?
Yeah, because that when it says like continuous and discontinuous stuff like that.
Okay. All right. So I'll point a few things out if you're not already familiar with WebAssign. If you were to get this question on the exam, the only thing that would change is the red numbers here,
Yeah.
and you actually can see how it propagates through the rest of the problem. So um, they they want the down here they're asking for the limit as t goes to positive infinity e of t, and they're asking you to look at this function here. So it could be written this way: limit as t goes to infinity 0.3 t squared minus 1.6 t plus 16. The highest degree term is all you really care about. The rest of this is not important. This is a parabola, and this does go to positive infinity. So they might have mentioned in class like the limit as x goes to infinity, x to the n, where n is greater than 1, that this always goes to infinity.
Okay.
Now they would have also, and it's kind of not really related to this problem, but they might have also said the limit as x goes to plus or minus infinity 1 over x to the n, where n is greater than 1, it goes to 0. Sometimes they put a number up here for that.
Okay.
Um, so I mean, maybe that's not useful yet, but this one I just wrote is. So the next one here, it's the limit as t goes to infinity. You've got to write e of t over I of t. So it's 0.3 t squared minus 1.6 t plus 16 over, actually just went by it here, over t squared plus 3.5 t plus 51. Now, do you need to show work on this exam, or are you trying to do it in a way where you understand by showing work? Because there's a few shortcuts if you don't need to show work.
So I took Math 210 last semester too, and I just remember the shortcut,
Okay.
but I would like to be able to like show the work.
Okay, so what you have to look for is the highest power
Okay.
in either the numerator or the denominator. So in this case, it's a t squared. So you divide the top and the bottom by t squared. It's a lot of writing, but it's 0 0.3 t squared minus 1.6 t plus 16 all over t squared all over t squared plus 3.5 t plus 51 all over t squared. And then
Okay.
you reduce. So you get 0 0.3 on top. This you're taking each one of these over t squared minus 1.6 over t plus 16 over t squared all over. Bottom here, same thing. You take t squared and divide it by t squared. So that's 1. 3.5t divided by t squared. That's 3.5 over t plus 51 over t squared.
Okay.
And then that thing I just wrote, which is this, it's kind of off to the side here, the limit, and I wrote it with this way with x, limit as x goes to plus or minus infinity, constant or a number over x to the n, where n is greater than 1, this always goes to 0.
Okay.
So how is that useful here? Well, the ones I'm going to circle all go to 0.
Okay.
They all take on this form here. So so this equals this whole limit equals 0 0.3 minus 0, because this 1.6 over t is applying this on the left here, plus 0 over 1 plus 0 plus 0.
Okay.
And that's where the shortcut is derived. Oh, it's 0 0.3 over 1. So it's
Yeah.
0 0.3. I can just look at the coefficients.
Okay. So the shortcut that I learned is like if you see that in the top numerator and the denominator they have the same
Yes,
power, it would just you would just like look at it and be like, oh, it's 0.3.
exactly.
Okay.
Exactly.
And then
And notice, I mean, like, again, if you get the same problem here, like this one's not red up here, so this is always, it's whatever that number, it's always going to be there. And
okay.
this is always going to be infinity. Um,
Okay. So say it was like 0.3 t to the 3 all over
that's
t to the 2.
yes, that's different. That's very different.
Okay.
Um, and I would point out that that wouldn't happen in this problem.
Okay. Okay.
So let's move on to the next problem, unless there's more to say about this one. Or I'm sorry, when I say the next one, we should probably do infinite limit problems like this one that says calculate the limit algebraically. Let me snip this in and see if, because it's related to this, it would be my preference. But you are the customer, you're the student I'm trying to help. So just let me know if you want to do something different than this one. Let me snip it in and see what we see. Oh, I'll send you a PDF copy of the notes when we're all done, and a link to the screen recording. So you'll have this, in a couple hours if you need it.
Okay. Perfect.
So this one is kind of like the one you were just asking me, but it's, you can do a shortcut here because you have a highest degree term
Okay.
there.
And it's
So
just
there's a 1 there and a 5 there, and it doesn't. If it were going to negative infinity, it would be exactly the same
okay.
value. There's a few exceptions, but I haven't seen one yet. They usually don't cover it in this class.
Okay.
Um, let's see. Is there? And did you send another one? You
I
did.
tried to
Okay.
pull everything I could with like infinity and stuff. Oh, the second one that says limit 0 to the plus.
Let me do those in a different grouping of questions.
Okay.
The infinite limits are kind of one category of limits that you're going to see. Um, so let's talk about this one. Like why? Like it really doesn't matter here, but let's talk about why. So roughly, this thing that you're looking at here can be approximated by 12x squared over 4x squared.
Okay.
And you know that it's going to be 12 over 4, which is 3. I mean, that's
Yeah.
how you got this. But it's going to negative infinity this time. Well, if you have a number and you're squaring it, does that matter?
No.
No, because it becomes positive. Same thing down here. So the sign cancels with it. So even if it was positive infinity, you would get the same thing.
Okay.
Now you might think, well, hey Matthew, what about, let me just make one up here. What about the limit as x goes to infinity, negative infinity, 5x cubed over 4x cubed plus some other stuff that we don't care about. We're just focusing on this.
Okay.
And this is negative. This is negative infinity. So when you cube a negative number, what does it become?
Negative.
Negative. And if you cube a negative number again, it's negative. So you have a negative over a negative. So it doesn't really matter. It doesn't matter whether it's plus or minus infinity. It always goes to the ratio of those numbers. Always.
Okay.
And the exceptions are not part of your class.
Okay.
So let's look at the as it approaches zero
Yeah.
question. That would be um, something that I would want to. Now, are you allowed to use your calculator, Desmos, anything like that when you're
Yeah, we can
on?
use our calculator.
Okay. If you graph this, are you comfortable graphing this?
Yeah.
Okay, so if you graph it, you're going to see that it looks like this and like this.
Okay.
And I would encourage you to graph it now if you haven't done that for this problem, just to get comfortable before your exam.
Okay. Yeah, I just did.
Okay, and make sure your window. If you don't remember how to do that, I can talk you through that. But the you should get something that looks roughly like this. I mean, it obviously be a little bit different on your screen, but something
Yeah.
like that. So what this is saying here, the limit as x approaches zero from the right. That means from the right, and that tells you where to start from the right. So as I go from the right, it approaches positive infinity.
Okay.
The limit as x approaches zero from the left here, from the left, also approaches positive infinity.
Okay.
It doesn't always, but this is very important. What I'm about to say is that these are what are called one-sided limits. One-sided limits always exist. You always
Okay.
get a number or infinity, but there is a case, and I'll just change this slightly. Let's say your function is 9 over x. If you were to graph that, it looks like this and like this.
Okay.
So the limit as x approaches 0 from the right, 9 over x from the right means I'm coming from the right, it goes to positive infinity.
Okay.
The limit as x approaches 0 from the left
Negative
here,
infinity.
goes to negative infinity. So notice both of these exist. One-sided limits always exist, but the limit as x approaches 0, this does not exist because they don't approach the same value. From
Okay.
one side, it approaches positive infinity. From the other side, it approaches negative infinity.
Okay. So if it was like the one where it was 9 over x to the 2, the limit to 0 would exist
Yes, exactly.
because they both go to infinity.
Exactly. Uh,
Okay.
the way you said that shows me you understand what I just said, which is great because you're going to see it on the test here.
Okay.
So we've got a question here about continuous, non-continuous. I can talk about that next. Is that okay, or is there something? Did I miss anything here?
That's perfect.
Okay. All right, snipping that in. Wow, that's really okay. Determine whether the given function is continuous on its domain. So there's many words that were probably thrown out in this part of the class. One of them was continuous. One of them might have been differentiable, and another was just whether it is a function or not. Continuous is probably the easiest one. From high school, you might remember it's like, can you draw without lifting up your pencil? And that's great, but it doesn't help you here. Um, this line, this is a line, and this is a line. They are both continuous by themselves. The question is, like, what happens here at this end point? This is an end point, and the other one's an end point. Like, do they meet at the same place? So like it could be that one looks like this and the other looks like that.
Is this something I could like graph?
I wouldn't graph it. It's much easier just to, I'm going to give you the recipe here, is to put the endpoint into the piece, the function. So we're going
Okay.
to put 3 halves in for x, 3 halves in for x. If you get the same value, you're successful. So it's 9 minus 6 times 3 halves. Is that the same as 6 times 3 halves minus 9? And I have no idea. We're going to calculate. I mean, it says it is, so we'll assume that. If you're allowed to use your calculator, you can just punch this right in. If you're uncomfortable putting it all in, you can do this part first and then subtract from 9. You'll see that this is 0 and that this is also 0.
Okay.
So
Yeah.
since these are the same, yes, it's continuous.
Okay.
It is not differentiable though at that point, and I don't know if that's something that comes up, but or if you remember, but that is something we could have a side conversation about. So
No, I don't think we learned about that.
okay. This does cover everything you sent in that there. Let me pull back up the list here of things that you want to work on here. This Word document. Um, so we've covered limits. How about the limit definition? And let me snip that in because this is one of those things where if you had to show work, it could be very difficult. If you don't have to show work, you can just sort of fake it. Um, in
Okay.
like this, the types of questions you would see here is where it says use the definition of the definition of the derivative, which is what this is called. It's the definition of the derivative um, to find the derivative. And then it would tell you, be like, okay, f of x is x squared plus 3 or 3x. And they want you to use this thing over here to find the derivative. Do you remember anything like that? Or
Yeah, I think so.
the
Uh,
thing is, if it's WebAssign, is you can just find the derivative. You don't have to
yeah, that's the
actually
thing.
show the work. So um, now we should do if that's clear, I think it'd be good to move on to product and quotient rules. Those are
Yeah, that's
often
something I want to look at.
unclear. So let me throw up a function here that I think you might see. So let's say f of x equals x squared plus 3x to the minus 1 power times 4x to the minus 3 plus 2x. And you're asked to find f prime of x.
Okay. And I okay.
Is this something you feel comfortable that you could execute?
Yes.
Okay. So I'll point out here that WebAssign doesn't care how you enter it. So you can make it as messy as you want. If I were teaching this to you in a classroom, I would tell you to make u x squared plus 3x minus 1, and I'd want you to find u prime or du.
Okay. So for this, isn't it where you okay, never mind.
This,
You continue. You keep going.
okay, so this is to find the derivative of u, you're going to use power rule. Power rule
Yeah.
of x squared is 2x. You bring the 2 in front and you subtract 1 from 2. Hopefully
Yeah.
that's familiar.
Yeah.
Here, you're bringing the negative 1 down, so it's minus 3x. You're subtracting 1 from the exponent, so it's minus 2.
Yeah.
Okay? Now, let's look at v. So this is u, and this is v. So let me actually make a small little adjustment here. Get rid of this because it's not relevant. So v is 4x to the minus 3 plus 2x. V prime, tell me what v prime is. You bring this minus 3 down.
Yeah. It's gonna be negative 12x to the negative 4 plus 2.
Good. Very good. Okay. Now, f of x, our original thing, is really u times v. This is u, this is v. The derivative, now I know your instructor uses f and g, but let me just for a moment use u and v. I
Okay.
can change it if you need to. So it's in words, it's keep the first function, take the derivative of the second, u v prime, plus keep the second function, derivative of the first, u prime v.
Okay.
Okay. And I think the words are sometimes helpful. Now, all you're doing is you're taking these things that you just calculated and you're pairing them up. So u goes with, v prime. This one goes here. These two go together. So we're gonna grab them here. So in WebAssign, you don't have to simplify, and you shouldn't, because you'll make more mistakes trying to do that than anything else. x squared plus 3x to the minus 1. That's my u. I'm going to pair it with this thing. Minus 12x to the minus 4 plus 2. There. Then I'm going to put this plus symbol, plus. I'm running out of room, so I'm going to come down here. U prime. Actually, I think I can fit it. 2x minus 3x to the minus 2. That's u prime times
Hmm.
v. 4x minus 3 plus 2x.
Okay, and then just leave it like that.
Leave it like that. It
Okay.
There might be one question where it says to simplify, but it wouldn't be this complicated.
Okay.
So it would be good. It would be good for you to do one now, or if you've got one in WebAssign, you want to throw up to me to look at, or I could just keep going to the quotient rule.
If you did you say you could just log into my WebAssign?
I can.
Is that easier, or should I just go pull some up?
It'll be faster for me because I can navigate while I'm doing this. Let me
Okay,
get the
yeah.
chat open,
Do you just
and
want me to type my stuff in?
yeah, I'll just say hi, and you can throw in your username and password. All right, there it is. A couple of the other people I'm helping, they've already had their first exam in this
Yeah, we
class.
were supposed to have it last Wednesday, but then my professor couldn't figure out lockdown browser, so
Yeah. Then they'll rush to get the next exam in, maybe.
yeah.
All right, Ferozaman. Yeah, I know about him. Feroz. Just it's loading. It's on another screen here. So you probably don't remember which homework it's in, do you?
For like product rule and stuff.
Uh, no, it's like there's all they're just giving me the assignments. It's not super helpful for this. Let me.
Are you saying like what like 10 point?
No, yeah, like is it 10.1? Is it like which one is
Oh,
it? And
um
maybe they're not open either.
you can go to past assignments and you can still look at them.
Yeah, I'm trying to get. Let me. Okay, there they are. Do you know which one covered? Well, these are all out. Okay. Yeah,
Um
I'm not finding anything. Either let me make one up. Or, well, no, it's better if you find one that you can work on.
yeah.
Or
It's
let me just give you another one here. This will be. So let's just say f of x is x to the minus 1 plus 4x squared, and then it's 3x cubed minus 2x to the minus 2. I just make one up here and then we'll continue.
okay.
So go ahead and give that a try. Take about 60 seconds and see if you can get that down.
Okay. Okay.
Let me know when you're done. I can just write out the answer. You can.
Okay, yeah, I'm done.
Okay, so we're gonna keep the first here, x to the minus 1 plus 4x squared. And you have to take the derivative of this thing. So it's 3, bring the 3 down. It's 9x squared. Bring the negative 2 down, so it's positive 4x to the minus 3 power
Hmm.
plus, okay, we're going to keep this one and take the derivative of this. The derivative of the first one is minus x to the minus 2 power. Bring the 2 down, 8x times 3x cubed minus 2x to the minus 2.
Okay, yeah, that's what I got.
Okay, so I was able to, I'm getting closer here. Let me just snip something in real quick because I know that these are sometimes challenging types of questions to look at. Um, a question like this, it's a story problem, word problem. So they give you a function, and they ask you to find this. Notation means derivative. Hopefully that is very clear
Yeah.
now. You did it fine here with the power rule, and then they want you to take this number and put it in for t.
Okay.
And that's depending on the instructor, they sometimes emphasize these more than they should, um, for that. So that was 10.6.
I'm
I don't know.
looking at 11.1,
Okay.
and that looks like,
Yeah, 11.1's got a ton of derivatives. Let me pull up this question because I sometimes know that this is unclear which derivative rules you're using and why. So this one just asks you to find the derivative, which is no big deal. You're using power rule here for the most part. But then it's like, okay, I'm using power rule. I get that. When are you using the difference rule? Well, the minus here, that's the difference rule.
okay.
The constant multiple rule is the number. It's the 9 in front of 9x to the minus 1. It's the 6 in front of x.
Okay.
So the sum rule would be if you had a plus somewhere
Okay.
in there. Uh,
Okay.
I don't see, so 11.1. Um, are you having, okay, so you're going up to 12.6. I see the review exam, but it's not available. Like you said, it's no
Is it,
longer.
what does it say?
Oh, that's exam two. I'm sorry. Review exam two. That's
Yeah,
the
I
wrong
don't
one.
know why it's not
Um,
in anymore.
I see practice RLDB
Yeah,
test.
that was something for lockdown browser.
Okay. Okay. Let's go 11.2 here. Okay. How about, are you doing elasticity of demand questions yet?
Gosh, I don't know.
Okay. So maybe you're not there yet. Let
Yeah.
me let me pull up this question too. This is one that I see often on these exams. Let me grab it.
Okay, also 11.3 has product rule and quotient rule ones. I just saw that.
Okay. So I'm going to snip this in. You can tell me, do you want us to do this kind of a question, or do you want to move to go back to product and quotient rules stuff? So we'll get
Those
to
I
all of it.
actually understand because the when it's what am I trying to say? For P of X, you just take C of X plus R of X, right?
Profit P of X. So the first thing here is that you have to derive R of X, which isn't R of X comes from this number here. It's zero point
Yeah.
0.9 times X. It's 0.9x. It's price, which is what was given there, times quantity.
Yeah.
Okay, so your profit function, which I'll write out profit. It's usually P of X is revenue minus cost.
Okay.
So the way that you got this here is you found the revenue function, which is 0.9x. Then you subtracted in parentheses this cost function all the way up here, 40 plus 0.1x plus 0.001x squared. You distributed the negative, and then you rewrote it. So you rewrote it as minus 0.001x squared because that's the leading term. You combine the 0.9x and the 0.1x minus 0.1x, it's plus 0.8x minus 40, and that's your profit function there. See, in step A, you already had to find R of X and take its derivative, and then you had to find P of X and take its derivative.
Okay.
But part B refers to some things from that aren't really asked you for. So, like this particular question, if I just briefly aside here, you have to find the revenue function, and then you have to find its derivative. You have the
Okay.
cost function, then you have to find its derivative. The profit function comes from the ones that are given, and then you have to find its derivative function which is r prime of x minus c prime of x.
Okay.
Um, and the reason I'm bringing this up is like part B where it says, well, what's the revenue? Well, that's this number 500. It's r of 500. Well, what's r? Well, you had to figure that out up here, down here,
Yeah.
which is zero point 0.9 times x. What's profit? Well, profit of 500, you needed to find the profit function, which is down here.
Okay.
Marginal revenue is r prime of x. And you can't get r prime of x. Well, you have it up here, but you had to find r of x, then find its derivative. Marginal profit p prime of x, that's here in this box, but it comes from knowing the profit function and taking its derivative.
Okay.
The reason this is a loss is because this value is negative.
Okay.
This right here, you're setting p prime of x equal to 0. You're setting the thing from right here, minus 0.002x plus zero point 0.8 equal to 0, and you're solving for x.
Okay.
And it should always be a positive number. And then you'll notice that these values match.
Okay.
Okay, now you said 11.6 has the
11.3 has product rule and quotient rule stuff.
11.3. Okay. That's where I was. Well, let's just maybe I clicked on something else. 11.3. Yes, it does. Okay. Okay, so let's do a quotient rule, and then we'll go to chain rule.
Yeah, I'm pretty confident on quotient rule. Chain
Okay,
rule is not going to be on the exam though.
well, that's good.
That'll be on the next one.
This one, you wrote your answer in a way that it formatted strangely, but I mean, there's so many online calculators that if you had access to that, I mean, I would use one to check your answer on these. Much like the product rule, you're gonna use a u
Okay.
and a v. Why did I write 24? And then a v here. V is 3x minus 1. So your y is really u over v. And then we need to find a
Okay.
derivative for each. What is the derivative of this top one, the u here?
Just 2.
Just 2. How about the v? What is that?
Just 3.
Just 3. So the derivative y prime, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And you'll probably have this on a reference sheet. Is that true? I know sometimes they hand these out.
Um, I don't think we get a reference
Okay.
sheet.
I would clarify that because you definitely got to memorize this and maybe just write it down right at the beginning of the exam so you got it.
Yeah.
Because it's easy to get it in the wrong place. And this one does say to simplify. I actually think WebAssign will take it without simplifying, but I'm not sure. So we're just grabbing
Okay.
values. So v is this 3x minus 1. It's right there. U prime is 2 minus u, which is 2x plus 4. V prime is 3 all over 3x minus 1 squared. So that's how
And
you
then
got the bottom part. Go ahead.
do I just simplify it then?
Yeah, so we're going to distribute this 2, distribute this 3. So the top becomes 6x minus 2 minus, and this is going to apply to everything, so I'm going to just wait to do that, 6x plus 12. Okay, so now I'm going to distribute that 2, or that negative, minus 6x minus 12. Those cancel, and you're left with minus 14 over 3x minus 1 squared.
Okay.
One of the things on WebAssign is you can do practice another. Are you familiar with that
Yeah.
feature of WebAssign?
Yeah. I've
Okay.
done that.
Okay. I would do that because your instructor literally will be grabbing questions from here for you to do that. Let's do one more of these or two. Actually, this eight kind of draws it touches on another topic that's probably going to be on your exam. So let's do this. Okay. Find the equation of the line tangent to the graph at the indicated x coordinate. So the tangent line, there's two steps here. The first one is you have to use x to get y because you need a point. Second
Okay.
step is you need to get y prime or f prime of x, and then three is you use f prime of x to get the slope. And and
Okay.
and if you can see it visually as three steps or four steps, whatever you want to do as your recipe, or really isn't that bad. So you first need to find f of 4.
Okay.
That's using x to get a y. So that's the square root of 4 plus 1 over the square root of 4 plus 3. 2 plus 1 over 2 plus 3. That equals 3/5.
Okay.
Okay, great. Now you need to find the derivative. This is the hard part. This is the part where you need the quotient rule.
Okay.
So your f of x is square root of x plus 1 over square root of x plus 3. Your u is the square root of x plus 1. Your v is the square root of x plus 3. U prime now, becomes 1 over 2 square root of x. And if you need me to cover how that is, I can be more clear, but
Isn't it because normally I write it as 1/2 x to the negative 1/2, or is that going to get like messy?
no, it actually doesn't. This is x to the 1/2 plus 1. So you're bringing the 1/2 down, x to the minus 1/2. I mean, these are exactly the same. Because you're not, you're using it, it could go either way. I guess I don't have an answer. It's probably whatever is more comfortable for you. Um,
Okay.
this one becomes the same thing, which is also the 1/2 x to the minus 1/2. So we find the derivative using the quotient rule. It's u over v as your f of x. I use u and v because it's f of x and g of x. It gets very complicated. Plus, they often put f of x here, so it's confusing
Yeah.
furthermore. So, I always remembered it in words. It's the derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared.
Okay.
We're just plugging in things now. So v is square root of x plus 3. U prime, I'm going to use this first one, 1 over 2 square root of x minus u is square root of x plus 1 times v prime, 1 over 2 square root of x.
Okay.
And then that's all over square root of x plus 3 squared. So let's just say this question didn't ask for the tangent line. I just asked you to find the derivative. I would put it in WebAssign like this with these parentheses.
Okay.
And I wouldn't simplify. I would just completely let it be exactly as it is here. So now if we go back up to our recipe says find the derivative. We've done that. Now we have to find the derivative to get the slope, which means you're putting 4 in for x. You need to find f prime of 4. So wherever you see an x, you're putting a 4 there. So that's the square root of 4 plus 3 over times 1 over 2 square root of 4 minus square root of 4 plus 1, 1 over 2 square root of 4, all over square root of 4 plus 3 squared. So it
Okay.
depend, this right here is 5. This is 1 times 1/4, so I'll show it here in case you want to look at it later. This is 3 times 1/4 over, this is 2 plus 3, so that's 5 squared. So it ends up being 5/4 minus 3/4, which is 2/4 or 1/2 on top. It becomes 1/2 over 25, which is 1 over 50. So now that you have the slope, I guess I didn't write this down. Step 4, Step 4 would be to write y minus y1 equals m x minus x1. So you have x1 and y1. You have x1 comma y1. If you recall, we put 2 in and we got out 3/5. That's your point. And then your slope is the number we just found. It was 1 over 50.
And you got 2 from.
I'm sorry, 4. Boy, that's
Okay.
it's the square root of 2, or square root of 4 just 2, but that's not what it's
Okay.
for.
I was like, wait, what?
So I'm writing this right down here. Y minus 3/5 equals 1 over 50 x minus 4. Let me just check the WebAssign. It's already solved for y. So here's how I would have entered this into WebAssign in the box here, is I would have kept this on the right, 1 over 50 x minus 4 plus 3/5. It will totally accept that, and you don't make any potential errors. Trying to insert, uh, write it in there.
Okay. Okay.
Okay, so we got about 5 minutes left here. What else can we cover? I see a question on kind of a word problem in electronics. No. Do you want? I can snip it in if you want. Is there another topic though that you need us to cover? Let me snip this one in. This question here looks like it could be challenging if you're not super comfortable with things. Um, you tell me, is this okay to go through?
Like, do I understand it or something?
Yeah.
Oh, yeah, no, I get that. Where you
Okay.
just find the derivative of 2.
Okay.
And
So the rest of this one is, I mean, it's there. You said that they won't cover uh, chain rule.
yeah, no, we
So let
just
me.
started doing that, and that'll be on our next exam.
So this one right here, like I would classify this as a chain rule question, but you like the way you're supposed to do this is you're supposed to expand it
And then use the product rule.
and then use no, actually then just use power rule. So if you FOIL this, you get 16x squared minus 28x minus 28x plus 49, and then you combine like terms. You get 16x squared minus 56x plus 49. That's still y. Y is still equal to that.
Okay.
Then dy dx, you just use the power rule.
Okay.
And that's why I was surprised that you were like, oh, we haven't covered the chain rule, but it really is a power rule question here.
Okay. Not bad.
Let me pull up the Word document you sent me, and let me see. So we've covered the derivative rules. We kind of covered tangent lines. How about average rate of change?
That I'm very comfortable with.
Good. We've covered one-sided limits. Um, we've covered revenue, profit, cost. We've covered continuity. Um, you're probably not using L'Hopital's rule yet,
No, I don't think so.
so I'm surprised it's there. Um, let's see. Is there any other sections that you recall that you didn't you didn't do well, didn't understand? Your grades look great. I mean, if the homework is any indicator, you'll do well in this test.
Yeah, see, I don't know, because now, because I'm retaking it, I am feeling much more confident now that I actually know what's going on versus last semester where I was clueless. So it's like very nice feeling comfortable going into the exam.
I mean this in a positive way. You're not alone in being a student that's had to retake a calculus class. A lot of students have to retake it, and
Yeah,
sometimes that's all it takes is seeing it again.
yeah, I honestly feel like I'm pretty ready.
If you understood what I was working through and you felt like you could reproduce these steps, you're going to be there. So let's end here. I'll send this to you as a PDF and a link to the screen recording. Thanks again for scheduling. And if you can ever help you again, let me know and be happy to be there for you.
Okay, thank you.
You're welcome. Bye now.